Probability, a theoretical approach. Suppose a coin is tossed randomly in air. We know that the coin can only land on ground in one of the two possible ways, either heads up or tails up. Here, we can assume that any outcome, head or tail, can occur. By this, we want to explain that possibility of getting a head and a tail is equally likely. Let's see another example of equally likely outcomes. Suppose we throw a dice once. What are the possible outcomes? They are 1, 2, 3, 4, 5, and 6. Every number has the same possibility of showing up. All numbers 1, 2, 3, 4, 5, and 6 are equally likely outcomes of throwing a dice. This is another example of the equally likely outcomes. Example of not equally likely outcomes. Example: suppose a bag contains 4 red balls and 1 blue ball, and you have to draw a ball without looking into the bag. What are the outcomes? Will the outcome of getting a red ball and a blue ball be equally likely? Solution: since there are 4 red balls and only 1 blue ball, you will agree that you are more likely to get a red ball versus a blue ball. Therefore, the outcome, a red ball or a blue ball, are not equally likely. However, the outcome of drawing a ball of any color from the bag is equally likely. Therefore, all experiments necessarily need not be an equally likely outcome. Let us understand it with the help of examples. Example: on throwing a dice, what is the probability of getting 1. An odd number, 2. A multiple of 3, 3. Perfect square of a number, 4. A number less than 4. Solution: by throwing a dice, we can get 1, 2, 3, 4, 5, 6. Therefore, total number of all possible outcomes is equal to 6. 1. Favorable outcomes for an odd number to occur is 1, 3, and 5. So, number of favorable outcomes is equal to 3. P, an odd number, is equal to number of favorable outcomes upon total number of possible outcomes is equal to 3 upon 6 is equal to 1 upon 2. 2. Possible outcome for getting multiple of 3 are 3 and 6. Therefore, favorable outcomes is equal to 2. P, a multiple of 3, is equal to 2 upon 6 is equal to 1 upon 3. 3. Favorable outcomes for getting a perfect square is 1 and 4. Therefore, number of favorable outcomes is equal to 2. P, perfect square, is equal to 2 upon 6 is equal to 1 upon 3. 4. Favorable outcomes for getting a number less than 4 is 1, 2, and 3. Therefore, number of favorable outcomes is equal to 3. P less than 4 is equal to 3 upon 6 is equal to 1 upon 2.